Audio started. And we're recording. All right.
We're live streaming right now, so your conversations may be overheard. And
hey, everyone, we're live streaming. If you don't want to be recorded, don't say anything until we stop. Is everyone okay with a photo of this little crew here? Okay. Anyone not agree? Okay.
Okay, welcome everyone to the Networkings lecture of Cyber Wizard Institute. So today we're going to be talking and playing around with servers and clients and protocols and how two computers can talk to one another over the internet. So I think a sort of surprising thing for people who are not programmers is that any computer is a server and any computer can be a client. And often there'll be the same computer could be a client and a server at the same time. This is really common. Instead, servers and clients are more about the role that a service takes. And there's also a distinction between server, as in a particular computer that's often tasked with the role of being a server, and then the kind of program that you can run that provides a service. So both of those are called server, and they're both used somewhat interchangeably. So just be aware that there's some sleight of hand jargon happening, and that's just how things are. So let's talk a little bit about packets. So packets are the tiny chunks of information that zip across the network, and it's how pieces of data get exchanged across the internet. So when you want to send a big message, like say we want to send this message right here, it's not super long, but if this message could be broken up into some even smaller messages, we could break it up into like the first half, and then the second half could be the second packet. And packets have these special headers that control what order the remote destination should assemble them in case the packets arrive in different orders for TCP. So what is TCP? TCP is a reliable transport mechanism. So there's this thing called an acknowledgement or an ACK in a TCP session. So every time you send a packet, this isn't strictly true, but every time you send a packet, you receive an acknowledgement from the remote host. But in actuality, you send a number of messages and you receive ACKs, big batches of them at a time. That's called windowing. But the simple model is just that each packet gets a response so that you can ensure that the remote destination got the packets that you sent it, because the internet is full of all kinds of routers and it's full of all of these kinds of links. Your messages could get split up among a lot of different possible routes, and those routes could go down or up a lot. A router can lose power, network connection can get severed, you can have congestion, there's all kinds of problems. So that's what TCP lets you, it lets you make certain guarantees about your network connection. UDP, on the other hand, doesn't give you that guarantee, although pretty much everyone just builds TCP on top of UDP, with just built for different trade-offs. So UDP doesn't give you those guarantees about your data arriving at the remote end. So sometimes you'll see it for games, and occasionally for streaming video or audio, but aside from that, it's not as used as TCP. So pretty much everything else that's not a game or streaming video is going to be TCP. And a lot of games and streaming videos will also use TCP. So the next thing we can talk about up the stack is this notion of a protocol. So a protocol is like a little language that two computers use to talk to one another. So some protocols that you've used probably every day are HTTP and HTTPS. This is how you can browse web pages, how you can fetch images and resources across the network. There's a whole protocol for that. A related protocol in terms of how it's specified is called SMTP, which is for email, for sending email in particular. The nice thing about a lot of these protocols here, HTTP and SMTP, is that they're called plain text protocols. So you can actually type out with the keyboard what the role that a computer program would normally play. So it's a really fun way and really instructive way to kind of play around with different network protocols. So there's more, like IRC. We have an IRC channel, CyberWizard Institute, that maybe some of you have joined. And this is also using a text-based protocol that we'll look at a bit later. So network services run on these things called ports. How ports work is, so every host has an IP address in a network. So host A wants to talk to host B, it knows its IP address, but just knowing the IP address isn't enough to make a connection, because you also have to know what port to connect to the other computer on. So a server will listen on a port that's sort of unknown number, like port 80, for example, is the default port for HTTP, or if you want to speak SMTP, that's on 25. So the server's job is just to sit there and wait for incoming connections. And a single server could have multiple different services provided. They'll just be on different ports. So you can have a lot of different kinds of services on the same computer. You don't have to buy a new computer if you want to run a web server and an email server. You can put all of that on the same computer if you want. Yeah, because the port system lets you run up to 65,000 services on the same system. Although, when a client makes a connection, it also creates a port. And the port is how the routers in between both connections know where to forward traffic. It's just another part of that that's brought along for the ride in the packet. So here's some more customary ports. IRC isn't strictly speaking in etc services, which is a file on your system if you're running Linux. That port, but it's another one. This is a really fun file called services. There we go. So this file gives you a list of all of the reserved ports in terms of protocol numbers. So this is just like a big specification. Not all of these are always used for their intended purpose, but this gives you kind of a rough idea. If all you know is a port number, you can have a good guess at what kind of protocol you might be by looking at this list. One other important thing to note about ports on a Unix system is that every port below 1024, you have to have super user access to listen on it. So I can use the Netcat program to create a small server. So if I listen on port 5000, that's fine. But if I listen on a lower port like 1000, hang on, I get a permission denied error that I don't get on a higher port. And the cutoff is 1024 for historical reasons. It's a power of 2, which is nice. It's 2 to the 10. But that's just how things work. So typically, if you're configuring a server and you want to listen on a low port, but you don't want to have your web server run as root, you can do some things with IP tables, or there's different ways to configure your system so that particular users can bind to low ports. So any computer can be a server and any computer can be a client, but what does that mean exactly? So basically a client is any computer program that initiates a connection, a network connection. And a server is any program that listens on a port for incoming connections. So a server is just a role, just like a client is just a role that computer programs can play. And in the same computer program, you can be both a client and a server with respect to a different protocol. It's more about it's more about whether you're connecting or whether you're listening than whether you have what kind of computer you have. And there are even more different kinds of network topologies we could have. So you can have servers and clients, but you could also have something more like a peer-to-peer system where, sure, you're making direct connections to other peers, but maybe there's some really ridiculous trickery that lets you connect to a peer without listening. It's basically like you trick the router into thinking it's already established a connection, because routers aren't typically very smart, so it's easy to fool them if you exchange some information ahead of time. So different kinds of peer-to-peer systems like WebRTC or I don't know, BitTorrent might work this way, maybe not. Can establish connections like this. WebRTC is really fun as well because you can use it from the browsers. You can make peer-to-peer connections in the browser without having a server. So, a really fun thing to do to play around with networks is, if you don't already have it on your system, install Netcat. So you might have the sudo apt-get install Netcat, or you can, basically if you type nc, type nc-lp or -l, depending on the version of Netcat you have. You might need LP or you might need L. And then in another session, hang on, you can do nc localhost space 5000, and now we're talking. So this is basically like a little chat program. That's all. This is just a really simple TCP connection. One side is listening and one side connected. And now they're just exchanging packets back and forth. Yeah, so here's what you can type. Either nc-lp 5000, you might have to sudo apt-get install Netcat or brew install Netcat or something like that. Or you might have to do nc-l, but then after you nc localhost and the port number, you should have a bidirectional communication mechanism. It's really fun.
If it's bidirectional licensing, one is listening while the other.
So it's bidirectional in the sense that once the connection is established, then the messages flow both ways. But one side listens first, but after the initial connection, packets go both ways. So go ahead and play around with Netcat as I talk about more stuff. But so some other kinds of network protocols we can have some fun with. Let's talk about HTTP. This is the protocol that web browsers use to communicate with web servers. So first we'll need some HTTP verbs. These are, you'll see more in a moment, but we have these verbs in HTTP that let us fetch a document with get, or submit a form with post, or upload a file with put. There's one called head as well, but it seems to have fallen out of favor. There's more. There's like delete and options and all kinds of obscure stuff, but these are very common ones. And people use these different verbs in ways in which they weren't intended, but it's quite common to just use them for whatever purpose you want. So how HTTP works is you have a verb, and then you have the URL, or the path, and then you have this list of headers. So headers are just like JavaScript, how you can have an object that maps keys to values with a colon. You do that in HTTP headers too, but there's no comma at the end. It's just a new line separated. So for example, if you type this into your terminal right now, ncgoogle.com space 80, and then type get, all caps, space, / space, http /1.1, host : space, google.com, and then hit enter twice. Well, you get some HTML and a response. So now we can sort of poke around at what this response we got, if we did it correctly was. So we got this message back from google.com that this document has moved permanently because our host is google.com. So it says that we should go to this place, www.google.com. So the server, just like how we sent headers, HTTP, the server also sends headers in its response. And the server, just like us, hits enter twice in its computer programming way. And we can see that here. So there's a gap with an empty line, and then it starts with the body of the response. So this is like the HTML payload, or the image, or whatever kind of document we're requesting. You can tell what kinds of document you're getting and how it should be rendered by looking at this header called content-type. So in this case, it's text, and it's HTML text, and it's in the UTF-8 character set. So that's the one with all the poo emojis, and that's the good one. So, so if we go to, so we can follow it. Normally your web browser will follow those headers automatically, but if we want to do this ourselves, we could do host www.google.com, hit enter twice, and now we get a sweet payload of some JavaScript and some HTML, whatever. This is all just like super minified stuff. There we go. So this is, I think this would be something like the homepage of google.com. And you can access this straight from Netcat because there's nothing special about HTTP. It's a plain text protocol, which is nice, so we can inspect it, we can look at it, we can poke around and read it. And all that we need is a program that speaks TCP. Yeah, question?
Are these notes on GitHub?
Yes, the notes are on GitHub under, this one is called Networks. Right, so different headers we can have. There's a whole lot of headers. If you read it, some of them will make some sense, some of them seem completely ridiculous and crazy, and the server can basically just decide to send whatever headers it wants, and you just have to kind of, as a client or a browser, just have to decide which ones you care about and do things accordingly. There's all kinds of specifications for how that should happen, but okay, so now let's make another kind of HTTP request. Let's do a post. So if you ever have a form in HTTP or in HTML, like for example, let's see, I don't remember if I put one here. Right. So let's make a form. So call it form.html. We can have HTML and body and stuff, but all that we care about is form. Form has an action. Action is the URL where the form should post to or get to, and it has a method. So in our case, because we want to make a post request, we'll do our post with by typing out post. We could also do get here, and we will submit to form, or like submit whatever. That URL can be whatever you want. So a form has a bunch of do a bunch of different things in a form. We can have a password, or we can have a name field, or a text field, or a text area, whatever we want. So we'll call our first text box blah, and our second one foo, and then we'll have a submit button. Cool, so if we type in this kind of a thing into an HTML form, the next thing we'll need is a way to host this form. So I think I've got an example of a little program you can use to host things, but let's just do something very simple. So remember how the action can be any URL. It's common for that URL to refer to the current server. So this path, because it starts with a forward slash, is relative to the current server. But we can do whatever we want. So if we want to intercept our post with Netcat, for example, just so we can look at it, let's just specify a URL. So we can give a full URL, say localhost 8001/submit, and now I'll start this little HTTP server on port 8000. Cool, so if I go to localhost 8000, I see my form.html, so there it is, our two text boxes. And now, the other thing that I'm going to do is start a server. So if I do nc-lp 8001, then all of the TCP traffic that comes in on port 8001 we'll see, and we can respond to it even. So, oh wait, Cyber Wizard, and if I click submit, now we get this HTTP request and our Netcat's out. So we see that, okay, so the verb was post, the URL was /submit, the host was localhost 8001, there's a bunch of other stuff. But importantly, we see blah equals, which was the first text field, cyber, and foo equals wizard. And this is quite simple to parse. There are modules to do it. You could also call .split on the ampersand character and then split on each pair of keys and values. If we want, we can type in manually a response. So if I type HTTP 1.1 OK, and now if I do content type text HTML, 2 enters, and then I do make some HTML. We'll see that in the browser. So what I was just typing in Netcat also shows up in the browser. That makes sense. And if I terminate the connection, then the little spinny spin stops spinning because the connection is ended. So that's how HTTP basically works. And this is the role of an HTTP server. So whenever you use a library to do this kind of thing, what the library is doing is pretty much what I was just doing here, typing stuff in with Netcat, looking at what the response was, generating a response based on what the input was. So I'll kill that. And there's some code in the lecture notes that can let us decode that. So why don't we run this for now? Oh, I forgot to install that package, but let's see. So we can use some modules, like this one called body, to help us parse this form. So instead of having that string where it was foo equals whatever and bar equals whatever, we can get an object, which is much more convenient to deal with. So if I copy paste this server program, and I do, this is a command of the day, xclip-o, on Linux at least. If you copy something, then it prints out what you copied to standard out. So it's very handy if you just want to write that to a file, which I just did. Great. Then I'll re-indent that a little bit. So this is going to listen on port 5000 for a form. If we have it listen on port 8001, we can use our previous example because there we were listening on 8001. So if I run node.server.js, that's going to listen on port 8001. And I'll rerun our server on port 8000. So if I go to localhost 8000, I click form.html, type some stuff, see the message OK from our server. What the server printed out for us was this message, blah, wow, and foo is cool. So with that information, we can then make our program like do something different. So if we want to, for example, instead of saying OK in the message, we could say we could do res.end blah equals and then params.blah. We rerun that program and refresh. Now our response contains the message that we posted. So you can take that information, put it into wherever kind of place you want. Whoops. Okay, so that's an HTTP post. There's other kinds like put and whatever, but they work pretty much the same. There's also different kinds of encoding. So you might see this like transfer encoding chunked. This is pretty cool because it means that you don't have to get the entire content from the server. You can just get little chunks at a time. And how this works is the server sends a number on its own line, like 3. That's the number of bytes that's going to be in the next message. And then it'll send another number. If that number is 0, it means the connection is over, but if that number is greater than 0, it means I'm going to send you more bytes. So there's another way we can do a lot of this HTTP stuff in an easier way than typing stuff into Netcat. We can use this program called curl. So you might have to sudo apt-get install curl or brew install curl, but once you've done that, you'll have a pretty sweet program for getting the content of web pages. So for example, if you do this, so the one caveat about curl is it has an annoying progress bar, but if you do -s, that goes away. So that's what I normally do. Substack.net, then you'll see the HTML of my website. And if you wanted to save that to a file, then you could use a redirect. So with the greater than, we can redirect the output of the curl program into another file, like mypage.html. And if we were to open that in a browser, we would see my web page, except my web page is doesn't have all of my assets and images because everything is relative to this file path. That's the one thing. But we can read it at least, so that's pretty cool. Some other fun stuff with curl, we can also do things like post requests. So if we take our server from earlier, so if we take our server from earlier and run it, so node server.js, that's listening on port 8001, I think. Yes. Okay, so now we can use curl-x to specify a custom HTTP verb, like post. And then we'll give it a URL, like localhost 8001. And now, if we want to send different parameters, instead of typing them in, we can do things like -d, blah equals, and then xyz, whatever. And we see in the response that blah equals xyz. We can send more parameters if we want to. But in this case, the server ignores those because that's just how we wrote it. Right. So curl is very sweet. There's heaps and heaps of documentation if you do man curl. The big ones that I use are -x, -d, -i to show the headers, which is kind of useful sometimes. So if you curl a page sometimes, like google.com, remember how we just got a redirect and we didn't get any content really. So if you want to print out what the headers are, you can do capital I. So if I do that on my blog, I'll see those HTTP headers, like content type, text HTML, date, and whatnot. Okay, some more protocols. Let's talk about SMTP. So this is a protocol that's used to send emails. It is notoriously insecure because it doesn't check anything, and it has no way of checking anything at all. So whenever you get an email from someone, who it says it's from, you should just completely disregard that. It's kind of strange that we don't have more of a problem with this, but I guess we do have a pretty big problem with email. But so if you connect to an email server, like if I connect to my local host, I think I'm running XN. There we go, yeah. On port 25, I see this message, 220 and whatever, and then it's a line and the date. Now I can run some commands, like, so SMTP is another text-based protocol, and you can, the first thing you have to do when you have an SMTP connection is you do hello and then the name of the server. So you could literally connect to Gmail right now if you knew what its email host is, which is not difficult to find. Then you could send yourself an email from like barack@whitehouse.gov or whatever you like. So I'll do that. Let's see. Right, so you do mail from barack@whitehouse.gov. Okay, look at this. The server just said okay. The server is not checking anything. So the next thing we can do is rcpt2, and then I'll send myself a message. Here I'm just running a local email server, so I'll just send myself my username at localhost. So Substack at localhost, also accepted. And the next thing that we have to do is type this thing called data. So data is where we type our message. And so enter message ending with dot on a line by itself. Very nice, very informative of SMTP to tell us exactly how to type email in with Netcat. So if the first part of an email message is normally the subject. So headers in email work very similar to HTTP headers. So if we want to send a custom subject, we just type subject, hello there, and then 2 lines, and now we can start typing our message. From the president. And then a dot by itself. And now we see 250, okay. And now we can just type quit. You have new mail. So in a Linux system, most configurations will print out a message on the command line whenever you get new mail on your local system. And then to read it, you can just type mail. There it is, barack@whitehouse.gov. So I can read it, and there's my message from the president that I sent myself. If you look closely at these messages, you can tell that this message is obviously not from the president because of DNS lookup and whatever, but it's really fun. A really fun way to screw around with your friends and get your IP address banned from Gmail or whatever, but whatever, it's fine. Yeah, so go ahead and do that. It's really fun. It's really easy. I was doing it, I think, when I was a kid because I found some tutorials online. I'm like, that's ridiculous. How's that possible? But the nice thing about it is it really peels the lid off of this kind of opaque system that we sort of take for granted, email. It's very easy to just type stuff in. The protocol is very straightforward for clients. You just use your fingers. Right, seems legit. Okay.
I got a question.
Yeah.
Why is that protocol still used for email?
So that protocol is still used for email because that is email. And we have so many servers deployed and we have so much infrastructure that depends on those basic protocols working, that it would be impossible to pull them out. I mean, there's lots and lots of complexity that makes it actually practical, but yeah, it just has such broad adoption that nobody could really make a new thing. So that's why. I mean, people make new things all the time, but they're just different usually. So like, there's Twitter, and there's Facebook, and there's IRC, and all kinds of fun stuff. So let's talk about IRC. So IRC is this really old school 80s chat program. So I forget exactly when in the 80s it's from. So this is a command line IRC client called IRSSI or IRC, and it's pretty nice. There's all kinds of like more GUI-centric ones too, but the nice thing about this one is I can run it on my server, detach from it, go offline, later hook up back where I left off without closing my client. So I like that about it. It's very popular among programmers because it is really simple and text-based, and nobody owns it, and it's one of those really open protocols that's probably probably never going to ever disappear entirely, just like email. So to have some fun with IRC, what you can do is just crack open Netcat, type nc irc.freenode.net space 6667, which is the port on that Freenode runs its IRC service on. I don't know if it'll start blocking us because we're all on the same IP address, but whatever, some of us will get through. So, yeah, space 6667. So how it works is you type nick space and then the nickname you want, and then you type user space, and then I forget, these can be different, but just put the same thing, just put the same nick twice, and then do irc.freenode.net. I forget exactly what these mean. At one point I knew this, but just pick a nickname and then type it a bunch of times. And then join CyberWizard by typing join space #CyberWizard, and you'll see all of these messages. If you want to send a message of your own, you can do privmsg #CyberWizard, and then a colon, and then whatever message you want. So if you want to send hack the planet, you can do it that way. So leave this up on the screen for a little bit. I'll do this myself as well, so you can copy from me. So nc irc.freenode.net 6667. Looking up your host name, yay! Nick. Cool beans. User beans. It might take a while for the initial connection to go through because it's doing a reverse TNS lookup. Oh, actually, it takes a while until you type all of that stuff. So you have to type the nick and the user part, and then you'll see a bunch of extra messages, like whatever that is, some messages of the day, and a bunch of garbage that I don't care about right now. And then do joins, space, #CyberWizard. Oh, sweet. So now, if I see in my other client, Cool Beans has joined CyberWizard, so it's totally working. And I see some of you have joined as well, so it's fantastic. I can tell because all of you on DSL, that's Static Fusion Broadband, who joined in the past minute are probably doing this along with me, which is fantastic. So if I type a message, hello, in your terminal now, in your Netcat session, you'll see this thing, colon substack and whatever, privmsg CyberWizard, hello. So what your client does when you're in multiple different IRC channels is, with your connection, you're getting messages like privmsg all the time, and they're to different channels. So your client just, depending on what channel you're getting the messages from, routes it to different tabs or what have you. And I can send a message of my own. So privmsg CyberWizard hack the planet. Hopefully some of you saw that just now. There we go. There it is on my other client. So IRC is super fun to play around with. This is also a really easy way to write a bot, an IRC bot. I mean, there are lots of good libraries, which I recommend if you care about and want to maintain your project for a longer period of time. But if you just want to hack something together to explore TCP, IRC is great. You can make a bot that reads each line from the server, interprets it, does something special sometimes. Like you can make a little calculator, you can make we have one that here at Sudorum, that when someone swipes into the door with a MagStripe card, it messages the channel, and it also has a command, !say, that when you give that a message, it pipes the text to the program called eSpeak, which is a computer speech synthesis program. So it sounds like that, if you heard it. Cool, so that is IRC, another text-based protocol. Those are the commands that I was telling you about. There's more commands, but these are all that you pretty much need to know to sort of hop around and have some fun. Questions? Any more about IRC stuff? Cool. So so far, all of these protocols we've been looking at have been text protocols. There are a lot of text protocols, but and they're very nice to implement because you can just look at them and figure out what they do just by inspecting. But there's a lot of other protocols that are not so much fun, binary protocols. So with binary protocols, you've really got to read a lot of spec sheets. It's like not as much fun. You've got to pack all of this binary data. It can be quite difficult. So SSH is one of those. So if you've ever used the SSH command to log into another server, then you're using a binary protocol. Just for fun, you can Netcat into a binary protocol. Like if you just try this command nc_substack.net, because I'm running SSH in my server, space 22, which is the default SSH port, you'll see this line, which is the only bit of text you're going to see before it kicks you. And then if you type anything else like help, it'll say protocol mismatch, and it'll just kill your connection because it expects a bunch of binary formatted data as the response. But luckily, if you use the SSH command instead, then you can connect to a server, assuming you have login credentials, which you don't if it's my server, unless you're me. So, another fun thing to do with protocols is you can use a program to inspect what kind of traffic is going over the wire. So, on this Wi-Fi, for example, we can look at all of the unencrypted traffic. Like, that should be a little bit scary, but everything going over this network that's not encrypted is public information. It's being sent out over the wire in a way that anyone can look at. How do you do that? Well, you can install one of these programs. Wireshark is a more GUI version. It's pretty fun to play with, though. Or I like to use this one called TCP dump because it's just a simple command line program. These both use a library called libpcap to access the network card on your computer. But if you're on an unsecured network, and even if it's a secured network, if you have the password to that network, then it's not secure anymore because anyone who also has the password can look at all of the unencrypted traffic again. So, good morning. So if you want to go the TCP dump route, you can, on Linux, do sudo apt-get install TCP dump. I don't know what it is on Mac, but it's probably something similar. And do sudo TCP dump because you need super user access, -X. Oh shit, I don't have it installed. Let me install it really quick. Oh, it's okay, it's pretty fast. Hopefully some of you are logging this traffic already that's going over the network. I think it's secure though. Okay, here we go. Here's a bunch of traffic that's coming over the network. A fun thing to do is if you pipe to less, like this. So now, and if I make it a bit smaller, so now we can see that, okay, so, oh, hang on, there's some words in here. So on this part in the middle is just all hex codes, so you can ignore that. It's mostly for debugging binary protocols. But this column here on the right is interesting. Validation.isu.apple.com. That's a plain text string. What else is in here? I see that someone's connected to an EC2 instance over SSH. I can't read that protocol because it's encrypted, but I do know that it's happening because I'm on this Wi-Fi. I can see that another packet from SSH. Usually you can get some HTML traffic by searching for less than sign, or search for a common tag like A. And just wait a little bit. There we go. Oh wait, no, it's not.
So even with encrypted traffic, you can tell like what's going from who to who else?
Yeah, you still know what servers are communicating, even if it's encrypted.
So is that what Tor is like trying to add or change so you know that's what they're trying to do?
Yes, so with Tor, all that you know is that the computer is communicating to another computer that is on the Tor network. That's all the information that you would be able to know from that. Usually I get some good HTTP traffic for this. There we go. Here's one. So if you search for the string HTTP, you usually get that in a header message as the server response or request. So here is an HTTP connection to meetup.com, and we could totally read this if we want. We can see what it's about. It's pretty scary what we can do with these programs.
Why is that so revealing?
What?
Are we just like seeing everything that's going on?
We're seeing what pages people are requesting on unencrypted web pages. So if we wrote a little script that just grepped for strings like that, we could just print out a list of URLs for people on your network.
Is that only on the Wi-Fi network that you're on, or is it on all the networks?
No, this is only this particular network.
Wi-Fi.
Yeah,
So
Wi-Fi.
everyone is connected to that on their network.
Yeah. Yeah, so hopefully this has been a little bit scary for all of you. You should think a little bit before going to a page on HTTP, even a page on HTTPS, because someone who's eavesdropping can look at least at what host is being requested, even if they don't know the path name or any more information about the content. And if someone submitted a password through an unencrypted HTTP connection, you would see that. Your password would be in plain text for anyone to look at and do stuff with. So this is a powerful tool. Please use it responsibly. Yeah, just a little. To make the text all on the right? Oh, I use TCP dump -S. Yeah.
And less.
Oh yeah, and I piped it to less so less is a pager. So here's the command that I did. Now would not be a good time to go to open any unencrypted web pages. Yeah, and the other one is called Wireshark. It also does the same thing, but it's more graphical, and you can use it to do some more powerful things if you want.
Can we don't put data from networks that you're not connected to?
No, you have to be connected to the network. Although, actually, that's not true. You can passively intercept traffic, but you have to have a kind of Wi-Fi device that can go into monitor mode. So in Linux, you do iwconfig interface name mode monitor to set your interface into monitor mode, and then you have to run like another program that uses libpcap to dump the traffic from your wireless card. But I mean, it makes sense. Everything that is going across the air, your wireless card is a radio receiver, so you can read it. And anything that's unencrypted is you're just sending it out to everyone within listening distance. Oh yeah, this is another fun thing you can do with TCP dump. If you only want to look at HTTP traffic, it has a little really simple scripting language in it. So if we want to look at all of the traffic on port 80, we can do this command. So there we go. We're getting, and port 80 is the unencrypted port. So 443 is HTTPS. So all of this traffic will probably be unencrypted. Yeah, there is one. So there's some core.com.
So is there a way to make your machine like only communicate over unencrypted ports? Like you can only listen for and talk on ports that are encrypted?
There's not really a straightforward way to do that aside from just only running software that does that. There's a Firefox plugin called HTTPS Everywhere. I think it's also available for Chrome if you care about that kind of stuff. The EFF has a lot of really good resources about different plugins and tools you can use if you want to avoid unsecured web pages.
So how does something like VPN fit into this? Because if I had a VPN connection somewhere that was on this network,
Yeah.
would you be able to see traffic?
So VPNs are usually encrypted. So all that I would be able to see if I was running TCP dump is that you were connected to a VPN. And that's all. Or I wouldn't know that it was a VPN necessarily. I would just know the host name. but I could maybe figure it out. Yeah, but that's all. Yep. And then everything that you went through that VPN. In that VPN network, someone running TCP down could see all of the unencrypted traffic, but I couldn't. Not from this network. Yeah.
What's an application for wireless for good? How would you apply this for good?
How would you apply this for good? By scaring people into knowing what they're doing when they use the internet? I don't know.
About any apps?
No, this is a really useful debugging tool. So if you're running services and you need to see what the actual data is over the wire, or if you're reverse engineering a piece of software, like, and you want to figure out what the binary protocol is, then these tools are really useful for that.
Is there any way to counter, like, is there any way to defeat counter
Oh, sorry, Kid Bart is loud.
Is there any way to have private messages within the server, like that are actually private?
Private messages within the server. Like, how do you mean private message?
Like not encrypted, but maybe it's only used if you have a specific code.
Well, you would just encrypt them. That's how you do that. That's pretty much the only way to do that. Yeah, and even if you encrypt your traffic, unless you do it very, very carefully, and there's a lot of ways to mess it up, sometimes you can figure out who's talking to who by different kinds of timing attacks and whatever. Yeah, so encryption is very difficult, but luckily some of the time we have nice tools sometimes. Yep.
In not showing the user's device number, what is the device number and can that be changed?
Oh, the MAC address, you mean?
Yeah, I guess so. That sequence there.
So let's see. The IP address is in here. I don't know if TCP don't print MAC addresses, but it's definitely possible to get MAC addresses out of here. No, this information is just the hex version of this ASCII data on the right. You can change your MAC address in software. I don't know how to do it on Mac though. Okay, so if you want to learn more about some of these different protocols, I put some links to these RFC files. So RFC files are like the most dry, nerdiest possible thing, but actually they're super good almost all of the time because they describe in great detail. Like this one is from 1982 about SMTP, and it just describes in excruciating detail how this protocol works. They're fantastic. I definitely recommend giving them a read, especially for IRC if you want to play around with that, and HTTP if you want to make servers and browse websites. So thanks, that's all that we have for now, but if we have time we'll have some other shorter workshops about making real servers too. So thanks. But right now it is free hack time, so ask questions, help each other. I'll be around, other people will be around who know stuff. Yeah. Yep.
So, like with the TCP protocol, like the one that has the acknowledgement,
Yeah.
isn't there some question? I'm trying to get my head around